Hi, my name's Mark. I'm a partner engineer on the Three Box Labs team, and today I'd like to talk about the two primary ways applications today are using did methods to authenticate users or authenticate themselves and writing data to Ceramic. And the first of which is did PKH. So PKH in this instance stands for public key hash, which means this did is associated with the end user's EVM compatible address or public key hash. And the idea here is it uses, or you can use this method to emulate a simple sign-in with Ethereum flow. And in doing so, you're creating a browser-side session for your users. And this instantiates an object capability to a delegated did key to write on that user's behalf. It's the only method accepted by Ceramic that allows end users to make browser-side writes using their, or link to their ETH address. So conversely, did key is actually the method under the hood that's used when browser sessions are created for end users, because what they're doing is creating a did key, and that did key has ability to write on behalf of that user for a limited amount of time. But it can also be used by applications directly if they want to write data to Ceramic and say, yes, like this data is owned by my application instead of being owned by the end users. And so what I wanted to do is cover how these two methods can be used within a simple React application. And so in going over to the code, I'll first start with this method that we commonly see using a contextual wrapper. So you'll notice that we're importing composedDB from this fragments component. And what I want to draw your attention to here, after we instantiate Ceramic and compose and import our model definitions into our compose client instance. Within the authentication sequence, you'll see that we're using the did session library to get a session if it exists or create a new one based on the account ID linking back to the end user's address. Their authentication method, so in this case, it's a browser-side wallet client-based method, and then also the tightly scoped resources. And in this case, we're referencing our compose.resources or the resources object off of our compose instance or compose client instance. And like I said before, because we're importing the model IDs from our definition file, we're keeping this session tightly scoped such that this session only has the ability to write across the models that our application cares about. And so what I'll do next is go into the actual client-side application code. And that is in components. And what I'll do in a moment is show you in the browser what this application actually looks like. It kind of emulates a simple paradigm whereby users can claim badges based on event attendance. And so in this case, what I did is, for the purpose of this demo, created two methods, one of which uses did PKH to claim a badge. And that is found in create badge. And what you'll notice is we're actually running the mutation query client side. And because we're accessing compose, which is imported, it's actually from the use composedDB context hook, again, imported from the same fragments component that we went over before. And because we're importing that and accessing compose, we know that the end user or the browser side user is already authenticated. And so when we go ahead and execute this mutation query, Ceramic knows to associate the end document with the authenticated user, sorry, down here. Conversely, what I also did is I created a create badge server-side method here. And the idea here is, perhaps there's a set of documents that your application needs that should be authored by the application itself instead of the end user. So what you could do is create, like we have a save with key API route. So a server-side route, and we'll actually jump to that. And you'll notice that what we're doing is we're importing a static seed environment variable and instantiating a new did. And when we're going through this process and authenticating it, this is creating a did key. And so when we're setting that authenticated did on our compose instance, we're switching over who the end did should be associated with the document that's created when we're running our mutation query. So in this case, it's going to be associated with the static did key. That's a result of using our static environment variable seed. And what I'll do next is actually go to what the application actually looks like. I want to show you what the session object looks like. And I'll go ahead and authenticate myself. Let's set it up with count 5. And so it's asking me to authenticate myself on the ceramic node, and in doing so, create a browser-side session. Again, these are the tightly scoped models that this session will have the ability to create mutations on. So I'll sign that. And let's look at the anatomy of the did session object. And in particular, if we go into did, you'll see that the primary ID is the temporary did key that's created. But if you look at the parent object, or the parent ID, you'll notice that it's the did public key hash of the same account that I authenticated myself with. And so now when we go ahead and create ceramic documents using did public key hash, it's using the did that I already authenticated browser side, whereas I've created this button that did create batch with did key that uses that server side API route that instantiates a did key server side that I mentioned before. And so 2 different ways to create documents in Ceramic, again, based on different use cases, if you want your end users to be the Ceramic controller of those documents, or if your application should be. And then one final thing, I wanted to provide one alternative to how developers might want to access the ability to create browser-side sessions. And so what some teams do instead of using this contextual wrapper, let's comment this out for a second. You'll notice that I created a store using Zustand, which is a state management tool. And kind of the same logic is used here. The same authentication flow, the same getter method is used off of the did session library. And what we can do is, again, use this and import this state store at any level within our application's components. And so if I go back to that main component that we were going over before, I'll go ahead and comment out the compose result of our use compose DB context hook. And instead, we'll use the wallet client from the use wallet client hook from WalletMe and our use store and the compose result, which will have in effect provide the same ability to have users make browser side writes. And we appear to have not authenticated ourselves. So it appears that I forgot to, oh, yes. There's one last thing that we have to do to allow this method to work. And I commented it out. So we'll we'll add back in this use effect React hook, which then sets compose based on the wallet client that's given to us by WalkMe, and compose and client. So now we can access the authenticated instance of our compose DB client. And so let's go back. And you'll notice that this is auth is coming from our store, which is what we want. And so now when we go ahead and generate a badge with the PKH, it works. Awesome. Hopefully you learned something new. Thank you.